In this video, the learner will graph the equation of a circle given its radius and center. So let's go over the definition of a circle. A circle is the set of all points in the plane equidistant to a given point in the plane called the center. So we're going to place our center at 0, 0. Now I'm actually going to create a circle using my compass. The compass is set to a certain distance here. So it's all points that are that same distance away from that center. So I'm going to now use my compass to make that circle. So every point on that circle is equidistant to that center. So if we take a look at one of the points on the circle, that point is a given distance away from that center. We call that distance, that segment, the radius. The radius is that segment from a point on the circle to the center of the circle. Or in a sphere, we can also have the radius of a sphere. So from the center to a point on the circle is a radius. And we could say there's a radius to every single point on that circle. Well, could we find the length of that radius? Well, sure, we could look at the vertical and horizontal distance to that point, and we could use Pythagorean theorem to find the length of that radius. So we'd have 3 squared plus 4 squared equals r squared. We'll let r equal the radius. So that's 9 plus 16 equals r squared. So 25 is r squared. Square root both sides, and so r is 5. So no matter where we are on that circle, we know that that's going to be a radius of 5. So if I take a look at this triangle here, we'll still have 3 and 4, and so 3 squared plus 4 squared will give us that length of 5 on that radius. No matter where I go around that circle, it's going to be the same, like here, here, and here. So I'll have all of those different radii from that center. Here I've plotted that same circle as before. We are given that point on that circle. That's our x and y coordinate that's on that equation of the circle. We're given the radius. We found that the radius of that was 5. So we have the equation of a circle that says x minus h squared plus y minus k squared is equal to r squared. This looks a lot like our Pythagorean theorem. X squared plus y squared equals r squared. And that's exactly where it comes from. It comes from using those little triangles to each point on the circle. The h and k are the center of the circle. So we could move this circle wherever we wanted, and that new point would be our h value and k value. So for example, our new center here would be -2, +4. Notice we didn't change the radius. We just moved the center. I could move it over here, and my new center would be +6, +4. So +6 would be h, +4 would be k. Let's go ahead and move it back to 0, 0. And let's write the equation of this circle. We have a center at 0, 0, and we know the radius is 5. So we're going to plug in those values for h, k, and r. So we have x minus 0 squared plus y minus 0 squared equals 25. The 25 came from the radius squared. So we have x squared plus y squared equal to 25. That would be the equation of this circle. Okay, here we have some practice problems. We're wanting to write the equation of each of these circles. We have a center at 1, -8, and a radius of 7. We're going to use that equation to plug in our values for our center and our radius. So the equation is x minus h squared plus y minus k squared equals r squared. H and k are the values from our center. R is the radius. So our value of h is 1, our value of k is negative 8, so we're going to plug those in. So we have x minus 1 squared plus y minus a negative 8 squared equals 7 squared. Now we're going to simplify a little bit. Y minus a negative 8 becomes y plus 8, and 7 squared becomes 49. So this right here, x minus 1 squared plus y plus 8 squared equals 49, is the equation of that circle. In part B, we have the circle graphed over here. It has a center at 0, 4, and we can count the radius here of 1, 2, 3. So now we're going to use the equation of the circle to plug in values for h, k, and r. H is 0, k is 4, and r is 3. So simplify x minus 0 to just x. Y minus 4 stays y minus 4, and 3 squared becomes 9. So this is the equation of the circle plotted here. Here are 2 practice problems I want you guys to try. Write the equation of each of these circles with a center at the origin and a radius of the square root of 10. A center at 4, negative 1 with a diameter of 8. Here we want to write the equation of the circle with a center at negative 2, 4, and the circle passes through negative 6, 7. Well, we're given this center, so that gives us our h and k values, but we weren't given the value for the radius. We need to find the radius. Since we know the radius of the circle goes from the center to a point on that circle, we could find the length of it by finding the distance between the center and a point that it passes through. We were given the center and we're given a point that it passes through, so we just need to find the distance in order to determine what the radius's length is. So find the distance between the points to determine the radius. Well, if we use the formula for the equation of the circle, we can take the square root of both sides, and that's our distance formula. So r equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now we're just going to plug in the points. We'll have negative 6 minus negative 2 squared plus 7 minus 4 squared. That gives us the square root of 25, or just a length of 5. So we now know our radius is 5. So now we have enough information to write the equation. We have our h and k values, and we have our radius now. So write the equation using h equal to negative 2, k equal to 4, and r equal to 5. We're taking those values and plugging it into our equation of the circle. X minus a negative 2 squared plus y minus 4 squared equals 5 squared. Simplifying that first expression, we get x plus 2 squared plus y minus 4 stays y minus 4, and 5 squared is 25. So this is the equation of that circle with a center at negative 2, 4 that passes through negative 6, 7. And here's a practice problem I want you to try. Write the equation of the circle with a center at negative 3, negative 5 that passes through 0, 0.